Hello, class. As I mentioned at the end of class yesterday, what I was going to do is I was going to record a video that goes over the last question from that review sheet that we weren't able to go over in class, just so that you have it and are prepared for when we start that test on Friday. So, what we need to do for question number 5 is we are going to start with this graph that they give us. It's a graph of a piecewise function. Our domain of f is from -3 to +3. What it wants us to do is it wants us to create an algebraic representation for f. So, as we discussed at the end of the class, there are going to be 4 separate sections for this graph. And what I'm going to do is, in order to help me write the individual equations for each of these sections, I'm going to draw lines for each of them. It says to assume that it's composed of straight line segments, so I know that if I was only dealing with this first section, the straight line would look like that. For my second section, the straight line would look like that. For my third section, my straight line would look like this. And then for my last section, it would look like this. So I can use all of these lines that I've just drawn in order to help me actually create what my function is going to look like. So, for f of x, again, it's going to be split up into 4 separate pieces. I'm going to use my squiggly bracket there to represent that all of these are going to be a part of the function of f of x. First up, I have my blue line here. This blue line is actually basically the easiest function of them all. No matter what my x is, my y is going to equal the exact same thing, my f of x. So that means my function is just x. My f of x is going to equal whatever x is. The thing is, I need to determine how far this goes. It's going to stop right here. So that means that we're going to go from -3. That's going to be less than or equal to x, which is going to be less than -1. It's not going to be less than or equal to because it can only be equal to -1 once. And we normally like to save that for the beginning portion. Speaking of that beginning portion, we can now look at our second line, our red line, which is going to go from here to here. And no matter what, for this entire red line that I've drawn, it looks like every single f of x is going to be -1. So I can just write f of x is equal to -1 for this entire section. This entire section lasts from -1 is less than x, which is less than 0. Because it stops at 0 and then goes on to the next line segment. Okay, so that was my next line segment. My third piece is going to start here at 0. It's less than or equal to x. And it's going to end at 2. Now that we have the domain of it, let's actually go into making the function. If we're going to make the function, we need 2 things. We need our slope and we need our y-intercept. Well, lucky for us, our slope is super easy. It goes up by 1 over 1. So its slope is just 1, so I can just leave that as x. Plus, what's our y-intercept? Our y-intercept is -1, so it would be plus -1. Or what I like to do, I could just do x minus 1. Either if I did x plus -1 or x minus 1, still the same function in the end. And lastly, we have one last segment. It's going to be this one here. and it's going to go all the way from 2 being less than or equal to x, which is going to be less than or equal to 3. Now, the reason we're doing or equal to is because in the end, we have to be equal to 3. And, well, there's no sections past this. So this is the only one that's going to be able to be equal to 3 in the first place. So we need to once again create our function. Instead of going up 1 over 1, this time we're going to go down 1 over 1. So instead of being positive 1, it's going to be negative 1. So my slope is going to be negative 1, or just we'll put negative x. Its y-intercept, it hits at the point 0, 3. So negative x plus 3 is going to be my piecewise function for f here. That's going to be my piecewise function for f. So this is what my original function looks like. Again, remember, I'm going to delete all of these lines that I put on here just so that we can look at the actual function itself again and remind ourselves what it looks like. So this right here is the algebraic representation for the function f that we have here. Part B and part C, we are going to take our graph and we are going to sketch a new graph that is going to be a transformation of it. So what I'm going to do for both B and C, before we even get started, I'm going to take this and I'm going to re-sketch it on our graph. I'm going to put it back on our graph. And there's our function. Let me plot that again on this graph. That's going to help us be able to sketch our graph even easier. Because what we're going to be able to do is we are going to be able to focus in on our key points for our graph here. We're going to be able to focus in on our key points for our graph. These are our transition points, our points where we swap. So let's take a look at all of these points. First off, we have the point -3, -3. Next, we have the point -1, -1. Then we have the point 0, -1. Then we have the point 2, +1, +2, +1. And lastly, we have the point 3, 0. So these are our points when we were dealing with our original function of f of y is equal to f of x. However, what it wants us to do is it wants us to sketch the graph of y is equal to 2f of x. So what we are going to do is we are going to take the points that we have here and we are going to transition them to our new graph. How are we going to do this? Well, if y is equal to 2 of f of x, then what I'm going to do is I'm going to take this y value that I have and I'm going to multiply it by 2. My x value stays the same of -3. My y value changes. -3 times 2 gives me -6. And it's going to be the same for each and every point, only changing my y value and multiplying it by 2. So -1 stays the same, but -1 becomes -2. Multiply my y value by 2 here. So now I have 0 stays the same. -1 becomes -2. Over here, with multiplying by 2, my 2 stays the same. My 1 becomes a 2. Over here, here's the lucky point. This point's not going to change at all. My x isn't going to change. My x stays 3. And then 0 times 2 still gives me 0. So this point stays the same. So now let's take all of our new points and plot them. -3, -6. -1, -2. 0, -2. 2, 2. And 3, 0. Now that I've got all of those points there, I can plot the sketch of my new function. It's going to look like that. Now we're not done with the question yet, though. It wants us to state what our domain is. And it wants us to state what our range is. Here's the good news about our domain. Our domain hasn't changed. We still go from -3 all the way up to 3. So -3 is going to be less than or equal to x, which is less than or equal to 3. However, for our range has, well, basically doubled. Because we've taken our range, which was originally from -3 up to 1, it is now from -6 up to 2. -6 is going to be less than or equal to y, which is less than or equal to 2. So our domain here stays the same, but our range is going to double. Okay, so that's what happened when you had 2 on the outside. What happens, however, when, for part C over here, we have 2 on the inside? Well, lucky for us, we already know what all of our points were. So let's replace all of the points here. And let's write down what those points were. -3, -3. -1, -1. 0, and -1. 2, 1, and 3, 0. So, last time when we were on the outside, we multiplied our y value by that amount. However, this time, instead of multiplying y by that amount, this time we're going to divide the x by that amount. So instead of multiplying our y, we're going to divide our x. So I'm going to divide my x over here by 2. And what do I get? Well, I'm going to get negative 3 halves, or negative 1.5. And my y value stays the same. We'll do the same over here. We're going to divide our x by 2. So I'm now going to get negative 0.5, negative 1. Lucky for us, this point isn't going to change at all, because taking 0 and dividing it by 2, well, 0 divided by anything gives us that 0 still. So this one is going to stay as 0, negative 1. For this one, I'm going to divide by 2. And my 2 is going to become a 1. My 1 stays the same, so I have the point 1, 1. And lastly, I should put the dividing 2 up here. My 3 divided by 2 gives me 1.5. And my 0 stays the same. So let's take these points, let's plot them. Negative 1.5, negative 3. Negative 0.5, negative 1. 0, negative 1. It's the same point as before. 1, 1. And 1.5, 0. Let's plot these lines in. So it still has the same relatively the same shape, just like this one. Except instead of stretching it, this time we're going to squish it horizontally. So instead of our range changing, this time our domain is changing. Our domain is being cut in half. It's going from negative 3 to positive 3. It's now negative 1.5 being less than or equal to x to 1.5. My range, however, isn't going to be touched at all. My range stays the same. I still go from negative 3 up to 1. My range doesn't change. So D and E basically just ask us to take what we just did there and formalize it into sort of a definition here. How does our range of y equals f of x compare to the range of y equals k times f of x when k is greater than 1? Well, what happened to my range here? It doubled. Well, my range doubled, and not like that. But my range doubled. It started from negative 3 to 1 and became negative 6 to 2. So when I had the 2 there, I multiplied my range by 2. So if I were to start with my current range of negative 3 being less than or equal to y, which is less than or equal to 1, well, I multiplied it by 2 before. This time, instead of multiplying it by 2, I'm just going to multiply it by k. And multiply both sides by k. So now it's going to be negative 3k being less than or equal to y, which is less than or equal to 1 times k is just, well, k. And since k is going to be greater than 1, we don't need to worry about any signs switching because we know that k has to be a positive number. What about when we had the k on the inside? How does that affect our domain? Well, if we remember, our original domain was -3 being less than or equal to x, which is less than or equal to +3. And when we had the 2 on the inside, I divided by 2. Well, what if instead of having the 2 on the inside, I have a k? Well, I divided by 2, so this time I'm going to divide by k. I'm going to divide both sides of this by k. Meaning that my new domain will be -3 over k is less than or equal to x, which is less than or equal to 3 over k. And that's how our domain will look for that. And we don't need to worry about any sign switching here because k is going to be greater than 1. So we don't need to worry about that. Problem solved. So with that, that's the end of question number 5. So that's the end of the review sheet. On Friday, as a reminder, we will be starting the test. You can use this review sheet in order to help you on the test itself. I'll see you guys all on Friday for us actually getting started on that. Until then, have a great day.